Hey everyone, in this video we will be solving linear equations. So let's get right to it. Solve the following equations for x. First, 5x plus 2 equals 22. So we're going to start by subtracting 2 on both sides of the equation, and that's going to give us 5x equals 20. Let's fix that 2. And then we're going to multiply each side of the equation by 1/5. And that's going to leave us x equals 4, which we can also write with our curly brackets as 4 in our solution set. Now, just a note, the reason why I like to multiply by 1/5 as opposed to divide by 5, even though they're the same thing, is in case one of our coefficients or our constants are fractional. Multiplying by a fraction, just in my mind, is simpler than trying to divide, let's say, 7/3 by 2. Much easier to do 7/3 times 1/2. So I just find it makes it more efficient in solving our equations. Now, whenever we solve a linear equation, always worth it if we have the time to plug back in and check that we got it correct. So is 5 times 4 plus 2 equal 22? So we have 20 plus 2 equals 22. 22 does equal 22. Our next example is 7 minus 3x equals 1. So I'm going to start by subtracting 7 on either side of the equation. Again, addition property of equality allows us to do that. We get negative 3x equals negative 6. I'm going to multiply by negative 1/3 on both sides of the equation. And we wind up with x equals positive 2, or written in our curly brackets, just 2. Again, take the time to check our answer. So is 7 minus 3 times 2 equal to 1? So is 7 minus 6 equals to 1? Well, 1 is equal to 1, so we solved it correctly. Our next example, 2 times the quantity x minus 5 plus 4x equals 17. So we're going to start by distributing that 2x minus 10 plus 4x equals 17. We can combine like terms on that left-hand side. 6x minus 10 equals 17. And we can add 10 on either side of the equation. Let's fix that 0. So that's going to give us 6x equals 27. And then we'll multiply both sides of the equation by 1/6. And that's going to give us x equals 27/6, which can be reduced, both have a common factor of 3, to 9/2. Or in our curly brackets, 9/2. So checking our answer here, we would have 2 times 9/2 minus 5 plus 4 times 9/2. Is that equal to 17? Let's just make sure I had that correct. 2x minus 5, yep. So here, we want to think of that as 10/2. So we're going to get 2 times negative 1/2 plus 4 times 9/2 equals 17. So we get negative 1 plus 4 divided by 2 is 2 times 9 is 18 equals 17. 17 does equal 17. So we did everything correctly. Our next example, x divided by 2 plus 6 equals negative 8. So we'll start by subtracting 6 from both sides of the equation. That's going to leave us with x/2 equals negative 14. We'll multiply both sides of the equation by 2. X equals negative 28. Or In our bracket notation, negative 28. Checking our work, negative 28 over 2 plus 6, is that equal to negative 8? So we'd have negative 14. It's not a very good 4. Let's fix that. Negative 14 plus 6 equals negative 8. Negative 8 equals negative 8. Good. 9 over 2 plus 3x equals x plus 5 over 4. So we've got a few fractions to deal with here. So I'm going to start by subtracting x from both sides of the equation. So that's going to leave us with 9 over 2 plus 2x equals 5 over 4. Subtract 9 over 2 from both sides of the equation. Now we're going to have to find a common denominator, so I'm going to replace minus 9 over 2 with minus 18 over 4. Multiply the numerator and the denominator by 2. And that's going to give us 2x equals negative 13 over 4. And then we're going to multiply both sides of the equation by 1/2. On the left side, that leaves us with just x. And on the right side, we get negative 13 over 8. So this is a perfect example to illustrate what I was discussing earlier. Instead of dividing by 2 on both sides, multiplying by 1/2 makes it simple to find that answer. Right? We just multiply the numerators, multiply the denominators, and we're good to go. So now plugging in to check our work, we have 9 over 2 plus 3 times negative 13 over 8 equals negative 13 over 8 plus 5 over 4. So on the left side, we get 9 over 2 minus 39 over 8 equals negative 13. Writing a little too fast. Negative 13 over 8 plus 5 over 4. So common denominators here. This is going to become, multiply the numerator and the denominator by 4. So 36 over 8. And here multiply the numerator and the denominator by 2. So 10 over 8. So on the left side, that's negative 3 over 8. On the right side, negative 3 over 8. So that means that we did everything correctly. And again, always worth the time to check. Next example, 4x minus 1 equals 4x plus 3. So I'm going to start by adding 1 to both sides of this equation. That's going to give us 4x equals 4x plus 4. And then subtract 4x from both sides of the equation. And we would get 0 equals 4, which hopefully we can all agree on the fact is never true. 0 never equals 4. So what does that tell us about this equation? That means that there is no solution. We cannot come up with any value of x that would ever make this true. And that should make sense looking back at the original problem, right? Take a value of x, multiply it by 4 on both sides, but on one side we're going to subtract 1, and on the other side we're going to add 3. Logically, it should make sense that those two values will never be equivalent. But we showed it out, we showed our work, and we came up with the correct answer of no solution. Right now there's no way to check our answer because there's nothing to check. Now solve the following equations for t. So they're just changing the variable up on us, okay, but nothing else changes. So our first example, 3 times the quantity t plus 1 minus t equals 2t plus 3. So we'll start by distributing the 3. So we have 3t plus 3 minus t equals 2t plus 3. Combining like terms on the left-hand side, 2t plus 3 equals 2t plus 3. Now we could go further, but I think we're at a good enough spot to stop. Now let's think about this. 2t plus 3 on one side, 2t plus 3 on the other side. So if we pick any value of t, should be the same on the left and the right. So that tells us that the solution set of this equation is going to be all real numbers. We can pick any value for t, plug it into this original equation, and that equation is going to be true. And try that. Pick 2 or 3 or 4 values of t, plug this in, and verify that you would get exactly the same value on the left as you would on the right. Now our last example, 6t minus 2 times the quantity t minus 8 is equal to 10 plus t. So I'm going to start by distributing 2 into the parentheses. So 6t minus 2t minus 16 equals 10 plus t. Now I'm going to distribute the minus sign so that we can drop the parentheses. So 6t minus 2t plus 16 equals 10 plus t. Now I could have just distributed the negative 2 to start, but I didn't see the negative right away. Distribute the 2, that's fine. I just had to do an extra step. Now combining our like terms, we wind up with 4t plus 16 equals 10 plus t. I'm going to start by subtracting t from both sides of the equation. Gives us 3t plus 16 equals 10. Next, we'll subtract 16 from both sides of the equation. So we get 3t equals negative 6. And then we'll multiply both sides of the equation by 1/3. So we have t equals negative 2. Let's fix that bracket. Okay, and this one, instead of writing it out, let's just check it verbally. So if we plug negative 2 in, we're going to get negative 12. Inside the parentheses, we get negative 10. Times 2 would be negative 20. So we have negative 12 minus a negative 20, which would be negative 12 plus 20, which is positive 8. On the right side, 10 plus negative 2 is also 8. So we did, in fact, solve this correctly. And this is a really good one to check your answer because a lot of students will forget to distribute that minus sign to both terms inside the parentheses. And if we check our answer, we may catch that mistake and then we'd be able to go back and fix it. Okay, so now it's your turn to practice. Okay, do a lot of solving, see a lot of different examples to get comfortable with it.